You are welcome to my channel. We are looking at JAMB stroke wide likely questions in physics as well as revision tests. In our last lecture, we considered some questions on energy. This time around, we are looking at some questions on heat. Let's look at the first question. An iron rod of mass 3 kg and at a temperature of 280 Celsius is dropped into some quantities of water initially at a temperature of 30 degrees Celsius. If the temperature of the mixture is 80 degrees Celsius, calculate the mass of the water. Neglect heat losses to the surroundings. Specific heat capacity of iron is 460 joules per kilogram per Kelvin. Specific heat capacity of water is 4,200 kilograms per kilogram per Kelvin. Now we have some options here. Option A, 0.76 kilogram. Option B, 2.43 kilogram. Option C, 2.31 kilogram, and option D, 2 kilograms. Now, before we solve this problem, let's look at some things. The question says neglecting heat losses to the surroundings. That is very, very important. And it is this one that will actually help us to eliminate some things in the question. Then, we are given the specific heat capacity of the iron as well as the specific heat capacity of water. Let's look at the solution of this. In our last lecture, I told you that any time you are solving question in physics, there are certain things to take note of. Number one, what are the information that we're given from the question? You need to understand the information you have in the question. Number two, you need to understand what you actually asked to look for. Now, let's start with the first one, the information from the question. One, we have the mass of the iron is 3 kg. So, mass of the iron equals to 3 kg. Then, not only that, we have temperatures. Here we have 3 temperatures. In physics, we represent temperature by theta. We use theta to represent temperature. The first one we have is 280 Celsius. For 280 Celsius will not be our theta 1 because we have theta 1, theta 2, and theta 3. The question says initial temperature of 30 degrees, that's the temperature of the water. So our theta 1 equals to 30 degrees Celsius. Then our theta 2 is the temperature of the iron. So theta 2 is 280 degrees Celsius. Then our theta 3 is the temperature of the mixture. The temperature of the mixture is, our theta 3 is 80 degrees Celsius. So we have brought out all the information from the question. Now, I'm coming back to this, neglecting heat losses to the surroundings. From this, we discovered that the heat loss by the iron is equal to the heat gain. The heat gained by water. I told you before that this statement will help us to neglect to eliminate some things. Why this is correct is because we are neglecting heat losses to the surroundings. If there is no heat losses to the surroundings, it means the heat that was lost by the iron, because the iron was 280 degrees Celsius, while the water was 30 degrees Celsius. So for us to get the mixture of the heat to be 80, the heat loss by iron must be equal to the heat gain by the water. You see, definitely, because the water is at a lower temperature, the temperature, after the mixture, the temperature will be higher. And the iron is at a higher temperature, the temperature will also come down. So the iron will lose some temperature while the water will gain some temperature. Neglecting the heat surroundings, heat loses to the surroundings, the iron, the quantity of heat lost by iron must be equal to the quantity of heat that was gained by the water. Now, from here, we are given the specific heat capacity. Let's call specific heat capacity of iron. Let's call it Ci. So Ci is 460. Then the specific heat capacity of water, let's call it Cw. Cw is 4,200. Then our M2 is the mass of the water. The mass of the water, and that is exactly what we are looking for. So we don't know the mass of the water, we put it a question mark, because that is exactly what we are actually looking for. Because it is what we are looking for, then we now have to get the M1 Ci. We have M2 is equal to M1 Ci bracket. Now, what is our theta 1? Our theta 1 is 30. Our theta 2 is 280. And our theta 3 is what? Our theta 3 is 80. So looking at that, then we have theta 2 minus theta 3. Theta 2 minus theta 3, theta 2 minus theta 3 all over, we don't know M2, but we have Cw all over Cw. And what is our Cw? Our Cw is the specific heat capacity of water. And what is the specific heat capacity of the water? The specific heat capacity of the water is 4,200. 4,200. So this will give me bracket theta 3 minus theta 1. Theta 3 minus theta 1. Now, we cannot fix in the value into this. Our M1 is what? Our M1 is 3. So we have 3 multiplied by our Ci is 460. Multiplied by 460 multiplied by the difference between theta 2 and theta 3. Theta 2 and theta 3. Theta 2 is 280. Theta 3 is 80. So 280 minus 80 will give me 200 times 200 all over my Cw, which is this one, is 4,200. Then the difference between theta 3 and theta 1. Theta 3 is 80. Theta 1 is 30. So I have 80 minus 30. 80 minus 30 will give me 50. So I have times 50. So this one becomes the value of my M2, which is the value of the water. Now, if you look at it that way, then we can cancel out this, we cancel this, this, we also cancel this. So we have, this one gives us 3 times M2 equals to 3 times 46 times 2 all over 42 times 5. All over 42 times 5. And if you do that calculation, we will come up with 1.31 times 40 46 times 2. That gives us 276 all over 42 times 5, which gives us 210. 210. So we have M2 is equals to 276 all over 210. If you do that, then we have 276 divided by 210, which gives us 1.31 kg. So the answer is 1.31 kg. Coming back to the option. Now, the first one says A is 0.76 kg, which means A is wrong. Then the second one says B says 2.43 kg. B is also wrong. And D said 2 kg. D is also wrong. It's C that says 1.31 kg, which is what we got there.